Today we will study the next topic, that is the differentiability of a function at a particular point in its domain. Say let x is equal to c. Let x is equal to c and c lies in the domain of the function. So we have to see whether the given function is differentiable at c or not. So what we will do, we will take the left hand limit x approaches to c, negative sign means left hand limit fx minus fc upon x minus c, and limit x approaches to c plus fx minus fc upon x minus c, isn't it? Or we will do another way. First of all, we will suppose let x is equal to c minus h and c plus h. After taking these two, we will go for left hand side limit h approaches to 0, fc minus h minus fc minus h, where h is a small value which is subtracted from the c, or here small value say h added to the c. So here it becomes limit h approaches to 0, fc minus h minus fc minus h. Here this means that is the value of the function at c minus h, value of the function at c, then value of the function at c plus h, where h is a small increment, here minus fc, and value of the function at c, divided by plus h, and here minus h. If both limits comes to be equal, and we have to use either this method or this. If both limits, that is left hand limit and left hand and right hand, here these are the limits, when they comes to be equal, so we call it, this limit, the value of this limit is called the derivative of the function at c, and this will be called left hand derivative of the function at c, or this will be called right hand derivative f dash at x is equal to c. In this way, left hand derivative at c, right hand derivative at c, if both comes to be equal, we say the function is differentiable at x is equal to c. Now I will take an example illustration so that this concept become very much clear to the students. So now what you are supposed to do, let fx is equal to x square. We have been given fx is equal to x square, and we have to see whether it is differentiable or not at x is equal to 1. At x is equal to 1, again listen, we have been given a function that is fx is equal to x square, and we have to see at x is equal to 1 whether this fx x square is differentiable at x1 or not. This is what the question is. So first of all, I will write down left hand derivative. What is the left hand derivative? Our limit h goes to 0 and value of the function at 1 minus h minus f1 upon minus h. This is our left hand as per the question we have done, formula we have done before this one. So now what is 1 minus h? f1 minus h means for x square we will put up 1 minus h whole square, and f1 means 1, we get the 1 here. Denominator minus h. It comes to be, on simplification, a square b plus b square minus 2ab minus 1 divided by h, get cancel, h common from the numerator, we have h minus 2 divided by h. So what we obtain? We will obtain h get cancel, that is minus 2. So value of the functions come to be minus 2. Sorry, one of the mistake we have done, it is minus h, it should be minus. So what we are supposed to take up common, what will be taking out the minus, h will be taken common, it will become, what does it become? It become plus. So our left hand derivative comes to be 2. Now let us go for right hand derivative. Right hand derivative, limit h equal to 0, f1 plus h minus f1 divided by plus h, that gives us 1 plus h whole square minus 1 square h. This is a square b square 2ab upon h, h again common, get cancel, and then proceeding to a limit. If we proceed to a limit, what we get? That is, we get plus 2. So both are equal. Remember, this is limit h equals to 0. Here it is also, that is understood, ki limit h equals to 0. We are moving here. So proceeding to limit means we will be the same way. We will say limit h equals to 0. Here also proceeding to limit means we are putting the value of h to be this 0, and we get the 2 on that. So when left hand derivative is equal to right hand derivative, so that implies, that tells us the function is differentiable at x1, function is fx x square. Or here you should take out the limit h equals to 0 and limit h equals to 0, go on writing along with that. And at the end we get the value on both the sides to be 2. So this is how we can see whether the function is differentiable at a particular value, at a particular point in its domain, whether it is true or not. Now you see, after doing so, let us come to our differentiation. Direct, what is the meaning of we will go for direct differentiation of a function. First of all, we will know certain formulae for that. In case we have to, was only to see whether the function is derivable or not, and now we'll go for, in case it is derivable, so then we'll go for the differentiation of the function. General differentiation or the differentiation at the particular point of the value of the particular value in the domain. So we'll do both. Now let us move. So in differentiation, first our formula comes to be, that is equal to, first of all I should tell you the symbol for the differentiation is ddx. When it has to be differentiated with respect to x, say ddx of x to power n, its answer would be, that is n x n minus 1. Or let us go for its illustration. In case there is a function, say x to power 9, you have to differentiate it. Your answer would be 9 x to power 9 minus 1, 8. So this is a n x n minus 1. Suppose you have another ddx of x to power, say 7 by 2. Its answer would be 7 by 2 x to power 7 by 2 minus 1. 7 by 2 minus 1. And that gives us, what will be give us? 5 by 2. So this is the differentiation of, so here, this is your n belongs to, and what is the value of the n belongs to real values. ddx of x to power n, this is a, or these are the illustration for these two. Now, after knowing this formula, let us go to the next one, that is your ddx of e to power x. Second one is ddx of e to power x, exponential function it is called. So, what is the answer for this one? E to power x as it is. ddx, derivative of e to power x with respect to dx is as such. Now, suppose you come across a question ddx of say e to power x to power 3. So, then what the answer must be? That is e to power x to power 3 as it is, and then according to chain rule of differentiation, that is into ddx of x to power 3. Chain rule says कि first of all we will differentiate e to power x3 as a whole, that comes as a formula ex as such, and here we did the derivative of x that came out to be 1, that is why we left it as e to power x. But here ex to power 3 and we get the ex3 as it is, then x3 gives us 3x square. So ultimately answer comes to be 3x square e to power x by 3. Or remember, the chain rule did not stop here. Here we differentiate x to ex to power 3, then x3, and then after doing x3, x was also differentiated. Its answer is always 1. Derivative with respect to x of x is always 1. Similarly, derivative of y with respect to y is also 1. Derivative of z with respect to any of the variable with respect to same variable, it comes to be 1. Now 3x square ex cube. This is what the answer we have here. This was the illustration for the e to power x. Now let us go for the next one. After knowing these two formulae, and the next one is here e was x. Here e to power x was an exponential function, and now let us go for any of the say log function. Suppose we come across derivative of log of x, and that is equal to 1 by x. 1 by x. Here I give you one of the illustrations. Suppose we have to differentiate log of x power 3. So then what is, let x square, log of x square to power 3. So then we have, first of all we will treat this whole to power 3. It comes to be 3 log of x square to power 2, and then by chain rule method log x square, and derivative of log x square is 1 by x square. Log x 1 by x, in case x square 1 by x square, then derivative of x square, then there is also one of chain rule says differentiate x square. So ultimately answers come to be 3 log of x square power 2 here into 1 by x square, that is x square 2x, this get cancelled. So we are getting the final value 6, 2 3 are 6 divided by x, or log of x square whole power this one. So this is the differentiation of log x square to power 3. What is this one? What I have written? It is the differentiation of, it is a basically derivative of log of x square raised to power 3. So this is what we have obtained. Log x square to power 3, and that we get 6 by x, or logarithm function. Remember, keep in mind, always defined for positive values. Log function is always what is called defined for positive values, and when we have got the square of the x, we will get the positive value. Square of any negative or positive always gives us the positive value. Now after doing the logarithm function, next we move to the next one is your, say, derivative of any arbitrary base to power x, ddx of, third one is your derivative of a to power x, and it is a to power x into log of a to the base e. Now its illustration, if we do, say we have been given 29 power x square plus 5. This is what we have. Say y is equal to so and so. So then its derivative will be dy by dx, that is your ddx of 29 x cube 29 and with raised to power x square plus 5. It is like this way. Now this is to be treated as a power x. The answer would be 29 to power x square plus 5 into derivative of, as per chain rule, derivative of ddx of x square plus 5 also, and into log of a. A is 29, log of 29. So this is the answer. Now this is left to be differentiated. We are supposed to differentiate this one also, x square plus 5. Derivative of any constant is 0. So we x square, we get 2x 50 into 29 raised to power x square plus 5. Further into log of 29 to the base e. So this is the answer for differentiation of this one. So this is the derivative. Y such given and its derivative is given to be 2x 2 and so. So this is the way. Remember this formula, a to power x is any arbitrary base, say any real number, etc. 29, 3, 4, 5, and we have to differentiate like this way. After knowing this one, let us go to the next formula. And what is the next formula we have with us? Is your derivative of, that is your, say, trigonometric function sin x, ddx of sin x, derivative of cos x, and derivative of tangent x. Derivative of sin x is cos x. Cos x derivative is always minus sin x. Tangent x is secant square x. And after knowing these three t ratios, trigonometric ratios, the next one sin cos tan, and that is your derivative of, say, cosecant x. Cosecant x is your minus, what is the derivative of cosecant x? Minus cosecant x into cot x. Derivative of secant x, that is secant x into tangent x. And the next derivative of cot x, that is minus cosecant square x. So in this way we are covering 1, 2, 3, 4, 5, 6 t ratios which are possible from the three sides of a triangle, that is the 6 trigonometric ratios. What do you observe? Whenever we have to find the derivative of any trigonometric ratio starting from the letter C, English letter C, cos, cosecant, cot, their derivative is having a negative sign, and those trigonometric ratios, not starting from C word, C letter, say sine, tan or secant, they have got the positive answers. They have got the positive derivatives. So sin x positive cos x, tan x its derivative positive secant square x, or secant x derivative positive secant x into tan x. So in this way, what I have told you, the derivatives of all the trigonometric ratios. After knowing the derivatives of the trigonometric ratios, let us go to the next, our certain certain quotient. So now we will move further in the differentiation, say exercise 5.2 of the NCERT. So before starting the question, the exercise 5.2 of the NCERT for class 12th, first of all I will let you know that we have got the two formulae, that is the product rule and quotient rule. And what is the product rule? In case we have been given the product of the two functions, say u and v, so then its derivative would be dy upon dx u. First of all, take up one function and differentiate the second one, ddx of v. Then put up the positive sign. Now take out the v into ddx of u. So what we have done, we have differentiated here v and here u. So both the function have been differentiated, and along with them the other function is there, and in between the positive sign plus have to be added to both of these. Now after knowing the product rule, let us go for the quotient rule. So what is a quotient rule of differentiation? In case instead of the product of the two function, we have been given the two function to be the in division, u upon v. So then what is the derivative of this one? Dy upon, say, dx. First you take the function in the denominator, that is v into derivative of u. Then put up the negative sign, u into derivative of v. The whole to be divided by square of the denominator. Complete function has to be squared in the denominator. So this is called the quotient rule. And next, let us go for the illustration of the quotient rule. Say I have got y is equal to sin x upon x square. Now this is the division of the two functions. So what would be the differentiation of this one? What would be the differentiation of this one? So first of all, written the denominator x square. So we will write down it is x square into derivative of the function in the numerator, that is sin x minus sin x into derivative of the function in the denominator, whole to be divided by square of the function at denominator, and square of x square would be x4. And the overall answer of this comes to be this. If on differentiation we get x square cos x, x square derivative of sin x is cos x, minus sin x as it is, x square derivative is 2x into sin x, and divided by x to the power 4. If we want to simplify it, in case we want to simplify it, x is common in the numerator, take out that common and you will be left behind x cos x minus 2 sin x divided by x cube. X cube, because one of the x in the numerator and denominator have been cancelled out, and this is the end answer, that is the x square cos x minus 2, isn't it? Now this is a quotient rule. After doing this one, product rule and quotient rule, so next I will like to tell you derivative of the composite functions. Derivative of the composite function. And what is the derivative of the composite function? Say y is equal to sin x square plus 9. Composite, why it's called composite? Because instead of sin x, its angle is defined by x square plus 9. X square plus 9. It is itself a quadratic. It is itself a quadratic. Or instead of 9, it may be 5, as it is given in the exercise 5. Doesn't make any difference, maybe 9, 5, 20, minus 18, etc. in this way. So now how to differentiate this one? Question number 1, exercise 5.2. How to do this one? dy upon dx, right on the left hand side. Derivative of sin x is your, what is the derivative of sin x is? Cos or x square plus 5 as it is. Along with this, we will write down derivative of x square plus 5. This is the way, that is called the derivative of this is called the derivative of composite functions. We have to apply this rule is called the chain rule, and it is a kind of chain we are forming. First of all, we are differentiating sine, then we are differentiating x square plus 5, and then we will differentiate x. That is one, may not write, we may not write down. This is a kind of chain we are doing, yani we are differentiating in the chain way. Sine, then x square plus 5, isn't it? Or x square plus 5 derivative is your 2x, x square 2x, and derivative of any of the constant, say 5, 9, any constant is always 0. So now we are here, 2x I am writing, and then cos x square plus 5. So this is the derivative of the given function. Y was to be sin x square plus 5, 2x plus cos. So this is what is another way we also call it derivative of composite functions. Now then let us move to the next question. What is the next question we have? That is derivative of cos, say y is equal to cos, here it is, instead of x we have got a sin x. Cos x might be, we would have, but instead of x I am having sin x. So I will write down y is equal to cos sin x, and its derivative, again it is a composite function. And what is the derivative of cos x? Say write down dy upon dx. Derivative of cos is minus sine into sin x, and then along with that ddx of, as per chain rule, this sin x also to be here, isn't it? So first of all, this cos x derivative gets minus sin x as it is, then ddx of sin x. So here answer for the sin x is cos x. So I write down first of all that cos x, and then this as it is, sine of sin x. So this is our answer, that is ddx of y. Cos x, sin x, answer comes to be minus cos sin x. Cos x derivative minus sine of sin x. As per chain rules, derivative of sin x, we get the cos x. This sin x, I put up here cos x. This is now let us move to the next question. The next question we have of this exercise, again, say, let us, next important question is question number 4. That is little more complicated. Y is equal to secant and then tan root x. Secant, that is the secant of tan root x. Secant of tan root x. So now write down dy upon dx. So what do we say? ddx of secant tan root x into ddx of tan root x into ddx of x. Root means power 1 by 2. So this is a complete differentiation, including the chain rule we have applied here. So first of all, secant and derivative of secant is secant into tan. So secant along with this angle and then tan of tan root x, or then derivative of tan x is secant square root x, and then derivative of x1 by 2 is your 1 by 2 x raised to power minus 1 by 2. So this is the answer. Or straightway we can say, if we make it power positive, the x would come in the denominator. So we may write down in the denominator and take its power exponent to be positive. So this is our root x. So in future, we just as I am saying, derivative of constant 0. So we can say whenever we have a derivative of root x, or 1 by 2, it will be always 1 by 2 root x after making it positive. So just keep it in mind, it will become quite simple during the differentiation. Many times you will come across x to power 1 by 2, a root of x. So we straightway can write down 1 by 2 root x. So now this is the answer for the question number 4. That was y secant tan root x. The derivative of this one is secant tan root x, secant into tan, derivative as per formula of the secant x. What is the formula for the secant x? Just recall, that is our ddx of secant x is, in case we recall, derivative of secant x is always equal to secant x into tan x. This is our. So same way, here it was secant into tan. So this comes to be from the secant x. And then as per chain rule, derivative of the tan root x. And tan root x gives us secant square root x. And after getting the secant square root x, we go for the ddx of root x, that 1 by 2 root x. So that is the final answer we have got. This is just the formula we have applied here. Now after doing this question, let us go to the next one, next important question we have with us. The next one is your question number, say 7. Question number 7, that is y is equal to 2 times cot x square under the root. So in the simple form, we can write down cot of x square to power 1 by 2. Square root means, in the exponent form, the square root sign gives us exponent 1 by 2. So now we have to differentiate dy upon dx. So as per our formula, first of all, what the formula I am going to apply here? ddx of x to power n gives us n x n minus 1. Here you have n 1 by 2, so write down 1 by 2, or then cot x square raised to power half minus 1 gives us minus 1 by 2. Then according to chain rule, I have got cot x square. Cot x derivative is minus cosecant square x square. Then further chain rule says differentiate x square also, and we get 2x. So this is the final answer, we get it. Now simplified form, 2 can be cancelled out, make it positive. If we make it positive, we get cot x square power 1 by 2, or here we have 2x and cosecant square x square negative sign. So this is the question number 7, the answer we get it. Minus 2x cosecant square x square, cosecant square x. These two get cancelled, cot square x minus 1 by 2 become positive in the denominator. So this is the answer we get. In this way, exercise, most of the important question of exercise 5.2 we have solved here. Only you have to remember the basic formula and chain rule, how to apply the chain rule during the differentiation. That is the most important in this exercise, and that is your 5.2. After this one, 5.2, let us go ahead to exercise 5.3. So what is 5.3 exercise gives us? Two types of questions are there. One of them is implicit function and another is inverse trigonometric functions. So exercise 5.3. First of all, I will tell you what is the meaning of implicit functions and then inverse trigonometric functions. Now the first question is find dy upon dx, and the question is 2x plus 3y is equal to, that is 2x plus 3y is equal to sine x. Now x and y both are mixed here. In the 5.2 we are taking the whole of the function to be y. Here x and y are being in between the functions. So we have to differentiate in the simple way, that is, this is a 2 scalar quantity, derivative of x ddx of x, scalar quantity ddx of y, and then ddx of sine x. Derivative of x is 1, 2, 3, dy upon dx as it is, and this is what we have to find it out. Dy upon dx, that comes up here, is equal to ddx of sine x cos x. Now our target is to find the dy upon dx, this one. So let us take all the other terms on the right hand side. So what we get? Dy upon dx, what is being asked to find it out in kind of implicit functions. We are most of the time we have to find the dy upon dx. Take the 2 to this side first of all. So we are left with cos x minus 3 divided by cos x minus 2 and divided by 3. So this is the answer, dy upon dx of the question number 1 of exercise 5.3, and this is called derivative of implicit functions. Implicit functions. That means x and y is being found in many terms. Y will be in many terms. Instead of only one y on the left hand side, it will be, that is lying in many terms of the quotient. So such functions are called implicit functions. So let us go for the next question. Again, one more question on the implicit functions. Say question number 8. So what does it tell you? Question number 8, that is sin square x plus cos square y is equal to 1. Again, we are supposed to find dy upon dx. We have to find dy upon dx. So first of all, I will differentiate sin square x. We get 2 sin x, chain rule ke accordingly ddx of your sin x base plus 2 cos 2 further 2 cos y into derivative of cos y, that is minus sin y, chain rule, or then further if we move on the chain, we come across with a y, that is dy upon dx. On the right hand side, constant gives us 0, derivative of 1 or any constant is 0. Look at the cos square y, how I have done it. First of all, 2 comes here, powerless, 2 minus 1, that is cos y. Then cos y of the base of this one, that is cos y gives us minus sin y. Then y gives us dy upon dx. Or our target was to find that dy upon dx. So remaining all the terms has to be taken on the right hand side. So sin x can be written as cos x. So I just write down 2 sin x into cos x. Here negative sign, 2 sin y into cos y into dy upon dx is equal to 0. Now, if in the previous classes you recall the formula of the trigonometric formula, 2 sin x cos x is always sin 2x. 2 sin y cos y again accordingly sin 2y. So we get left with dy upon dx equal to 0. Now let us take the sin 2x on the other side. So that gives us minus sin 2y into dy upon dx is equal to minus sin 2x. So let us cancel out the negative sign from both the sides. If I cancel out the negative sign from both the sides, so we are left with sin 2y dy is equal to sin 2x. But our target is only to find the dy upon dx. So dy upon dx would be our sin 2x divided by sin 2y. Sin 2x divided by sin 2y. So that is our final answer for this one. So here, in case you are unable to apply the formula, yet you are unable to recall in the examination 2 sin x cos x sin 2x, you can leave it as it is. In the numerator you will be writing down 2 sin x cos x upon 2 sin y cos y, 2 will be get cancelled, yani that is sin x cos y, sin x cos x upon sin y cos y. But better if you are able to apply, it is very simple, and by practice you will always able to recall, recognize it whenever the sin x cos x, and along with that 2 comes up straightway, sin 2x, sin y cos y 2, sin 2y. Okay, so this is how, this is our what is called derivative differentiation of the implicit functions, and what we have done today, implicit functions and the composite functions. That was the exercise 5.2 and this is exercise 5.3, that is the implicit function. Thank you for watching, or in case you have got still any doubt etc., anybody can contact on this phone number. It is being given 987 303 0349. Thank you for watching.